Okay, let's look at the hallmark 2.2, problem number 10. Alright, so we want to find the vertical asymptote of this rational function. Alright, so let's do that. Alright, so remember that at the vertical asymptotes, a function has to blow up. So only way we can do that is when the denominator becomes 0. Alright, so let's solve that. So you have both guys has x in it, so I'm going to pull x out. Alright, then if you factor x out from 5x, you get 5 left. And if you factor x from negative 2x squared, you would have negative 2x left over. Alright, so this is equal to 0. Alright, so you can see that here. So either x equals 0 or let's say x equals, so we have to set this guy equal to 0. Right, so how would you get that? Let's see. Alright, so this is going to be, alright, I'm going to add 2x to both sides. So you have 5 is equal to 2x. Then we can just divide through by 2 to get the 5 halves is equal to x. Right? So it looks like a smaller value would be x equals 0, and a larger value would be x equals 5 halves. Right? So let's type it in. Right? So we have a 0 there and a 5 halves. Right? So let's find the correct picture. So we have a vertical asymptote at the 0 and the 5 halves. Right? So you have a 0 here and a 5 halves. So this looks promising. Right? And this one also looks promising there. So, and this one actually, so vertical asymptote, almost actually all of them has the right location. Right? So we have to look at something else. Right? Then we're going to look at the limit and see if we can catch that. So looks like, let's see, I'm going to look at, let's see, how about this? Let's look at the limit at x equals 5 over 2. Right? So the difference is, looks like we have to make a decision based on here. So we got to look at the limit of this function. So you have x squared plus 3, and then you have I'm gonna put the factored out version of the denominator. Right. So we're gonna look at the behavior around the 0. So x approaches 0 from the negative side. Right. Then also we look at the limit as x approaches 0 from the positive side, and see we can get the value. Alright, so you have a 5 minus 2x. Alright, so let's do that. So if you plug in 0, 0 plus 3 is 3 on top. And you have x is 0, going to 0, so 0 from the negative side times 5 minus 2 times 0 is 5, so we have that. Alright, so you have 3 is a positive number, and 5 times 0 with a negative, so it's going to be 0, negative, right? Which means that this tells you that 3 divided by 0 is going to be big, but the positive divided by negative is negative, right? So this guy is the same way. So you have a 3 over, it's going to be 0 from the right times 5. So in this case, you have a 3 over 0 from the positive side. Positive divided by positive is positive. 3 divided by 0 is going to be big. Right? So we have that behavior. And also, we can do look at the behavior of limit of this function, x squared plus 3 over x times 5 minus 2x. All right, so then as x approaches 5 halves from the left, and we do the same thing, and x approaches 5 halves from the right. All right, so let's look at that. All right, so x is going to 5 halves. 5 halves squared would be 25 over 4. So I'll just write the 25 over 4 plus 3. And then you have a 5 halves times. If you plug in a 5 halves here, it's going to be 0. Right, so if you put slightly bigger than 5 halves, so it's a 2.5, slightly bigger than 2.5, 5 minus 2 times something slightly bigger than 2.5 is going to be slightly negative. So we have that. Right, so you have positive divided by negative would be negative. Right, and this is going to be a positive number divided by 0, so infinity here. Right, the same thing here. We plug in, so it's a 25 over 4 plus 3, just a positive number. And you have a 5 over 2 times, it's going to be 0, but this one from the negative side, so you have 5 minus 2 times something slightly smaller than 2.5, so it's going to be slightly positive, right? Positive divided by positive is going to be positive, and then positive number divided by something close to 0 is going to be big, right? So let's look at this behavior. So if you're coming from the left, it's going to go to negative infinity. All right, so let's see if we can find that. All right, first one goes to negative infinity, so first one's good. All right, second one, there's no picture, so this second one is not going to be it. All right, then we have, let's see, third one goes to negative infinity, and this one also goes to negative infinity. So those are still okay. And then if you're coming from the, let's say from the right, it goes to positive infinity, right? So this one goes to positive infinity, first one. Third one goes to positive infinity, and the fourth one, there's no graph, so it shouldn't be. So it's going to be either first one or the third one, right? So let's look at the this one. So I'm going to look at the one coming from the right at 5 halves. It goes to negative infinity. And if you look at the picture, the first one doesn't even have a graph. And here, it's approaching from the right, it goes to negative infinity. So this is going to be the only correct one. So that's the correct one. All right, so let's submit for testing. All right, it came back, and that looks like we got the vertical asymptotes correctly. And we have the correct picture as well. All right, that's it. I hope that this was clear.